I'd like to show you something that you might find quite interesting. This is a Fluke 189 multimeter. Now, this is a meter that we use at work, and this is a meter that was actually written off probably 10 years ago by a new engineer who started. Obviously I'm not going to mention any names or anything. I'm not going to mention where I work or anything, because that wouldn't be right. But I would like to point out there's two subjects to this really. Firstly is how stupid people can be, and secondly how well and how strong and how reliable these instruments can be under the most extreme misuse and distress and basically lack of common sense. This is a Fluke 189. This was a meter bought for this new engineer when he started the company. These are quite a high spec unit, and they certainly were in their day. They've got data logging, they do the normal things like frequency, fairly straightforward meter, but they do have the data logging facility that we don't really ever use or never use. But this engineer, it was an HV, he still is actually, an HV engineer, and was using it for checking, well, whatever he wanted really. He's an engineer, he knew what he was doing in theory. I I found this in the scrap pile and asked the question, well, what happened to that meter? It's only, it was only, at the time it was only about 6 months old. And I got the story from the chap who actually had to sign the scrap form, who only bought it, funny enough, the same person who actually bought it actually had to sign the scrap form about 6 months later, because this engineer had trashed it, and told me the story of what this engineer, in closed brackets, supposedly an engineer, did to this meter. What it turned out was, it was I couldn't believe it at first. I thought he was joking, and I actually had to go and ask the engineer if that's what he did, because I couldn't believe the bloody stupidity of the bloke. This is a meter that's rated, it's a Cat 3 meter. Now it's a good, they're good quality Fluke meters, they're lovely meters, rated to a maximum of 1000 volts. So it's not an HV meter, but it will work probably safely up to 1000 volts, no problem. And probably you could push it to probably 1500 volts, but anyone with any common sense knows that puts a lot of electrical stress on these meters. So yeah, apparently I picked this meter up from the scrap pile. I said, what's wrong with this? And straight away there's this smell of acrid burning. And he said, the engineer who was using it apparently decided he was going to apply a little bit more than 1000 volts. So I said, oh, do you know what he plugged into it? And apparently he said he was quite forward with it. He said, yeah, he plugged it into 20,000 volts because he thought it would handle it. Well, straight away, I think I came up with a couple of expletives saying what a waste of bloody space this bloke is, which is, I still believe actually, even though I can't mention his name. He's a really nice chap. He's very, very intelligent, very sociable, a lot of knowledge, but bloody useless when it comes to anything, lack of common sense. Anyway, I'm not going to go on about it anymore. He knows who he is if he watches this video. So switched, I thought, well, what's happened to it? At 20,000 volts it's going to be, trashed. So I said, it was being scrapped, so I said, well, I'll take it away and I'll have a look. So I'm just going to take it apart now. I have already repaired it, but I want to just show you what happened to the meter when he plugged it into 20,000 volts. Now, I was amazed when I plugged batteries in it. I got some form of a display. It was it was like the processor was still running, and I was gobsmacked that it must have had a massive flashover inside, and yet the display still, it's like the processor still put up with it, and it kept going. So this is the inside of the meter here. Now initially it looks okay, doesn't it? Obviously the fuses were okay because the current involved was fairly negligible, but what happened was it just arced. If you've got a 0 volt connection here and you put 20,000 volts here, this thing's just going to flash over. And that's what amazed me, that an engineer, I'm not an engineer, but I would have expected an engineer to have known that. with a common bloody sense that you're going to put a high potential between the two connections. So we let's just have a look, pop it out, and I'll see if I can show you what's happening. Remember how to get it apart, because it's been a while since I've taken it apart. Now these are lovely built meters. They've got lots of protection inside. They've got the MOVs and transorbs and that sort of thing, and NTCs to protect the unit from abuse, from sort of things like short circuits and over voltage and things like that. So they're a resilient meter, but they're not cretin proof, you know what I mean? You need to have a little bit of common sense. So this is the inside of the meter. Now it looks quite clean here, and probably initially you can't see what's wrong. Let me just zoom in so you can see a bit better. Now if you see around all this resistor network here, you can see here I had to cut all this board out, and this board here, where are we? Behind this back of this resistor has all been cut out because all of that had burnt. It was black all the way through. So what I did was I got a Dremel and I dremeled all that resistor, that board out there, trimmed all this board out. And then what I did was I took another meter apart that was waiting for calibration to get all the values of the components, because all of these components were totally and utterly black, you know, absolutely carbonized, totally up. And if you see here, I've changed the surface mount resistor here, a little blue resistor just here. Let me just point, first thing to point with, it'd be a bit easier. So we've got changed the surface mount resistor here, this little blue resistor here. These capacitors and transorbs were all fried. Now I rescued those from a scrap Fluke DVM where the display had, not DVM, a scope where the display had packed up. So I replaced all of those with the right values. These resistors likewise were totally fried and carbonized up. They've been replaced with similar sort of components from a different unit, and some of the resistors I actually bought in. So basically I rebuilt the whole lot, and the worst thing was trying to getting it to work properly. Once I powered it up, it obviously damaged all the EEPROM settings, so I had to go through the full calibration process on it. Now it's actually nice and easy to calibrate these meters. So I cleaned all this up and I powered it up, and initially it sort of showed signs of it working, but not on all the ranges. Some of the ranges wouldn't work at all, and I was thinking, oh, it's burnt out all the resistor network. But I went through the full calibration process after I'd sort of washed all this board out with isopropanol and gun cleaner, and just basically, because obviously we need no carbon at all in here. Any carbon in here will affect the performance of the meter. Rebuilt all that. As you can see on the back, has all been cleaned out. This resistor is sort of, you can still see a bit of carbon here, but because that's totally isolated, there's no conductivity across the track to adjacent points. That's good. So yeah, basically stripped it all out, cleaned it all up, went through the calibration, and to my astonishment, the thing worked. It worked absolutely fine. All the ranges were working okay. There was no problem at all with anything. The only problem there was a dicky switch, one of these dicky contactless switches, these rubber pad switches. Now, these are this is the switch here that sort of got everything got. There was just an explosion of carbon inside. You've got to remember that, you know, it went up with such a firecracker. Now these are the carbon impregnated contact switches here. Now, there's a little tip that I picked up. You see on the top of these rubber, they're usually black, but you see these are silver. I painted these with silver paint, and that works really well, and it recovers the switch contacts back again. So the switch is working absolutely fine. But you needed to clean all the carbon off, and then paint a bit of silver paint on there, and then you get the contacts back onto the switch. So the moral of this story is, despite the stupidity of this chap over voltaging this poor old meter, they survive. It survived the 20 times its rated input voltage, and it's, apart from the damage to the board, the process is still working, and that's, you know, that's quite something for a meter to be able to withstand that sort of abuse and still come back working. And this is a lovely meter. These are very good. They're probably a bit dated now. I see a lot of people using these key sites and Agilent meters. I see Radio Cruncher uses the Agilent meter, and you can see how much more responsive, how much faster the gate times are. Where these are fairly slow still, it's still for basically a freebie meter. It's a lovely piece of kit. So I was going to pop it back together again, and then I'll just quickly show you it working. Let's just reassemble it. I did actually leave this comment on the Fluke website for other users of Flukes, because I love Flukes. I've had Flukes for a long time now, and I noticed I was looking through some reviews on old meters, and I came across the EV blog with Dave Jones, and he was doing tests with putting a large charge into the meters to see how well they handled protection, and he did it with one of the Fluke 73s, the early 73s that I use a lot of, which I was a bit annoyed about actually. I mean, I know it's only an old multimeter, but it did show how well the meter actually put up with it. The protection on it, it protected the front end of the meter. It didn't work again afterwards. I don't think they tried it again afterwards, but it did show that between that and a sort of like a cheap Chinese meter you buy on eBay that just blew itself to pieces and caught fire, and just can't withstand that sort of abuse. So let's just pop it back together. Now this meter, I know you haven't seen this before. This is the one that usually sits at home and gets used at home if I need anything, but I think I'm going to start using this in the workshop now, because it has got other options on it that the basic Fluke 73s haven't. So pop that back together. So I suppose the repair cost me about 10 quid worth of components, which is quite good. So switch it on. And you can see the displays. Let's put the backlight on. I don't know if I've got them. There's the backlight. So we got AC volts, AC millivolts, DC voltage, DC millivolts, ohms, continuity testing, nanosiemens, capacitance, diodes, temperature, microamps, AC DC. That's the scale for doing the data logging. You've got various max min holes, rel, or null out something, and you've got the secondaries for sort of like logging, data logging. You've got fast min max, and that's quite useful actually. Auto hold, so that's like the first contact touch, and it will just hold the figure that it sees first off, which is nice. That's quite a useful feature. And actually the 73s have got that, but it's you have to hold a button down first. I don't use it an awful lot, but it's quite useful if you're trying to do something one-handed and you just want to just do it. Because for example, you say you can't see the meter, you're doing something and you touch it, you can come back and then look at the meter and you can see what the figure was. Manual range adjustment, and then you've got setup menus for how long the backlight stays on and things. So let's just plug it into a voltage standard just to show you. Now I calibrated it probably must have been 10 years ago or so, and it hasn't been calibrated since. But let's just see what we get. Not the right leads really, but this will do. So I'm plugging this into my voltage standard, my Time Electronics voltage standard. You can see here. Let's get it in view. Get out of the box so you can see it a bit easier. Okay. So let's go to the millivolt range, and we'll just do a quick show you what it does. So let's go and set it to, that should be 1 millivolt. Yeah, 10 millivolts, sorry, yeah. So there's your 10 millivolts there on the scale, you can see that clearly. That should be 100 millivolts, that works okay. And then half a volt, so that works fine. there's your 500 millivolts on the volts range. So it all works okay. And now you can go through by calibrating it with this calibration button on the back. And you can download the information off the internet, but it's very straightforward. All you do is you give it a standard, and then you basically just program it to accept that voltage standard. So you don't need any special software or anything like that. It has got the Fluke infrared link, which we never use. Just check it for continuity. Make sure the leads out. See that there? So there you go, that works fine. Continuity mode. And you can see the buttons all work okay. So there's a moral of the story is, and what I'm trying to say is, these Fluke meters are extremely rugged. They're extremely well built, and they will put up with a lot of abuse. And as you can see, I don't know if you can see that in the light there, it's still got its plastic protective coating on because it wasn't in service long enough before it was written off. Anyway, thanks for watching, and I hope that was of interest. And I highly recommend these Fluke meters. They are a little bit expensive, but they are well worth it if you're into electronics.